morning, my dear students. My name is Anjaneya Sharma, working as physics lecturer in one of the reputed institution. Today we are going to know a very important concept for all competitive exams. You will be given definitely one question. Okay, so that is about vectors. Okay, so in order to know about vectors, let us take some small examples. Suppose a bar started from this point, covered say 3 unit distance in horizontal direction, say x direction, 4 unit distance along y direction, and 5 unit distance along z direction. So you want to know its displacement. This you can calculate through our vector concept. Okay, or else if a girl walking on the road on a rainy day, so you can calculate relative velocity of rain with respect to girl, or in what direction she should hold the umbrella to protect herself from rain, is also known through vector concept. Okay, or take another example. If a person rowing his boat in a river, so in what direction to reach the opposite end? So this is all we are going to know through our vector concept. Okay, now let us see about first problem. That is, there is one bird covered 3 unit distance along x direction, 4 unit distance along y direction, 5 unit distance along z direction. So this can be calculated easily through vectors. Now we are going to solve this problem. Say this is plane, x-axis, y-axis, z-axis. Say instead of 3 units, say the bird covered A units along x direction, okay, B units along y direction, C units along z direction. So you want to know the displacement. So coordinates are A comma B comma C from origin, having coordinates 0 0 0. Okay, so distance between them, no? So that is equal to length of this vector. Distance between them will give us length of this vector. You can represent this in the vector form, that is A bar equal to AI plus BJ plus CK. Why? It is covered A unit distance along x direction, B unit distance along y direction, C unit distance along z direction. So its magnitude, okay, is equal to distance between them now. So that is nothing but under root A minus 0 whole square plus B minus 0 whole square plus C minus 0 whole square, which is equal to root over A square plus B square plus C square. So this is nothing but magnitude, or you can say length of a vector. Remember how to find the length of a vector? By using a formula, root over A square plus B square plus C square. Okay, so this is one model. Okay, so remember, vector means a physical quantity, one which has got magnitude as well as direction. Now let us take another problem related to direction. So north, south, west, east. So whenever a body covers distance along east direction, you should always take multiple of I cap. You know, I cap is a unit vector. So whenever a body cover distance along horizontal direction, we always take multiple of I cap. Okay. North side we always take J cap. Okay. West side minus I cap. South side minus J cap. Okay. North east side, remember I plus J by root 2. Okay. Northwest side minus I plus J by root 2. This is northwest. Okay. Southwest minus I minus J by root 2. Okay. Southeast plus I minus J by root 2. So if you know this, it is easy to solve any problem to find displacement. Suppose you have given a question. A drunkard covered 10 root 2 units towards northeast, 10 units south, okay, 10 root 2 units towards southwest. You want to find the resultant displacement. So a drunkard started from a point, covered 10 root 2 units towards northeast. So I said whenever a body covers distance in northeast direction, it must be multiple of I plus J by root 2. Okay. So resultant displacement is equal to 10 root 2 into northeast na. So I plus J by root 2 plus south side. So minus J na. So minus 10J. Okay. Plus 10 root 2 units towards southwest. So I take minus I minus J by root 2 into 10 root 2. Okay. So when you further simplify, you can find resultant displacement. Okay. So now we are going to know how to add two vectors geometrically. Now we are going to know addition of two vectors geometrically. So it is very simple. Once you know this, you can solve a more number of problems. Okay. Now we are going to know about addition. Now we are going to know how to add two vectors geometrically. So let us suppose this is the first vector you have taken. This is the second vector, say B bar. Now you are going to add these two vectors. How? Very simple. So first we will trace the first vector as it is. Okay. Then you take the tail of second one. So this is tail. Tail of second one to head of the first one. This is head. Okay. So you are taking the tail of second one and adding to head of first one. So thereby, one side is left. Now, so this represents resultant in reverse order. So order means, see, this is initial point. This is final point. Right? Initial point, final point. Right? So final. Okay? So it is called reverse order. So how to add two vectors? Very simple. So take the tail of second one and join it to head of first one. Then one side is left, which is taken in the reverse order, will give us resultant. So using this concept in rain and umbrella or boat and river problems also we can solve easily in the competitive exams. Okay, so let us take an example. Say this is a river vector. Let us assume river is flowing in this direction. So V or be the velocity of river. Okay, so there is one river flowing in this direction. Now a swimmer or else a boatman moving perpendicular to the direction of river flow. Okay, so you want to know the resultant direction. Okay, resultant direction of the boatman with respect to ground. Okay, say this is our problem. V R be the velocity of river. So a boatman or a swimmer moving, okay, perpendicular or normal to the direction of river flow. So he is moving perpendicular to the direction of river flow. Okay, so you want to know the resultant direction. That means if anyone observing it from outside, they'll be knowing that in what direction this boat is moving. Okay, so in what direction the boat is moving. So if anyone is observing, so they know the resultant direction of the boatman. Okay, how to add two vectors? So you know it is very simple. You always take the tail of first one and you add it to head of second one, right? So this is the procedure we are following. Okay, taking the tail of first one and joining to head of second one, right? So this is velocity of river. So this is velocity of boatman or swimmer with respect to river, because when he is rowing his boat or swimming in the river, he will be knowing that in what direction he is moving. So here the boatman knows that he is moving perpendicular to the river flow, but anyone observing it from outside, so they knows that the boat is moving in this direction. Okay, so this observer from ground knows that this is the direction of boatman. How? You know, you are adding the head of second one to tail of first one. So you know, closing side taken in reverse order will give us resultant. Right? So this is the direction of the boatman with respect to what? Ground. So if anyone observing from outside, that they knows that this boat is moving in this direction. But as long as the swimmer is in the river, he knows that he is moving only perpendicular to the direction of river flow. Okay? So according to swimmer or boatman, he is moving perpendicular to river flow. Okay? But one who observes it from outside knows that he is going in diagonal direction. It is like this. So boatman feels that he is moving perpendicular to river flow, but anyone observing it from outside, that they know that he is moving in diagonal direction. Okay. Now under this you will be given a number of questions. So let us assume D be the width of river. Okay. Now you want to find time taken. Okay. Time taken to cross the river. Okay, so you know time taken, okay, is equal to width by corresponding velocity. You know, VBR means velocity of boatman with respect to river, means he is taking reference river only, because in the river now he can only compare his speed with reference to river only. So that is why time taken to cross the river is T equal to D by VB, or means velocity of the boatman with reference to river. Okay. Now they may ask you to find the resultant angle with respect to normal. Okay. So from here if you are taking tan theta, okay, with respect to normal, means boatman is velocity of river by boatman river, means velocity of river by velocity of boatman with reference to river. Okay, so theta taken as tan inverse VR by VB R. But if you notice, that is one who observing from outside, so they knows that this person is not reaching to the opposite end. Instead of opposite end, he is reaching some other point. No, so this you call drift. Okay, means instead of reaching to the opposite end, he reached some other point. Okay, so let us assume this is P, Q, R. So boatman rowing his boat in the direction of PQ, but he is not reached to Q. Instead of Q, he reached to R. So this part we call drift. Okay, so how to find this distance? Okay, so drift or distance. Okay, speed is equal to distance by time now. So distance is speed into time. So velocity of river into time taken. No, so that is nothing but VR into, okay, VR into time taken. That is width of river by VBR. Okay, so this for our convenience will take dW. dW means width of the river. Okay, so this part you call drift. Means boatman moving perpendicular to the direction of river flow by taking river reference, but he is not reached to the opposite end. Instead of that, he reached to R. So this distance you call drift. Okay, so very simple. This is the direction of river flow. Boatman moving perpendicular to the direction of river flow by taking river as reference. Okay, but when boatman velocity is added to the river, thereby he'll be going in this direction. This can be observed by one who is standing on the ground. So this is called velocity of boatman by taking reference ground. Okay, so it is also called short time. So because he is moving perpendicular to the direction of river flow, so that is why in this case only the boatman reached the opposite end quickly. Okay, now instead of perpendicular direction, say the boatman or swimmer moving at an angle theta with respect to normal in this direction. Okay, whereas a river, so river flowing in this direction and he is moving in this direction. So you want to know the resultant. Okay, so this is the direction of boatman or swimmer with reference to river. Okay, now again we are using same procedure in order to know the resultant. Okay, so that is first you trace the vector. First vector is traced as is. No, so over here it is a river vector, right? So you are adding the second vector, that is a velocity of boatman with reference to river. Because he is swimming, he can take only reference river only. He cannot take other than river. No, so this is velocity of boatman with reference to river. So whenever is velocity is added to river, see, tail of first one added to head of second one. So you know the closing side, now closing side taken in reverse order will give the resultant. So that is velocity of boatman with respect to ground. Okay, so if anyone observing it from outside, they can notice that the boatman is moving exactly the opposite hand. Over here, definitely the boatman will reach to the opposite end. Okay, no drift in this case. Okay, now you want to find time taken to cross the river. So let us assume dw be the width of river. Okay, then time taken is width of the river by corresponding velocity in the direction. You know it is VB now. So velocity of boatman with respect to ground. Okay, so you can find angle also with reference to river flow. Okay, so from here if you are taking, you know, sine theta you can take, because you know opposite hypotenuse. So you can take sine theta is equal to velocity of river by velocity of boatman with reference to river flow. No, then the resultant angle will become 90 plus theta, nothing but you know sine inverse VR by VBR. Okay, now how to find VB? This is known to you, this is also known to you. Then you can find dW by root over, you know, VBR square minus VR square. That is, you know, these two are known to us now. So that is why velocity of boat with respect to ground you are taking in this way. Now, so in this case also, you know very well, we are using only addition of two vectors. That is taking the tail of first one and adding to head of second one. Closing side taken in the reverse order will give us resultant. Okay. Now we'll discuss about rain and umbrella problems. Okay. Rain and umbrella problems. Okay. Suppose when a girl is moving on a rainy day horizontally. So when she is standing, she knows that rain falling perpendicular. No, but whenever she starts running or moving, no, then she finds that rain falling over her at some angle. Then you should know in what direction she should hold the umbrella. Okay, in order to protect herself from rain. Okay, so this is all we are going to know now. Okay. So here you are taking two vectors. Okay, two vectors. One is rain vector. Say VR. Okay, and a girl moving horizontally with speed, say VG. Okay, so VG direction she is moving by holding an umbrella. Okay, so VG. Whereas rain falling over her with speed VR. Now you want to know resultant speed with respect to girl. Okay, so she want to know the speed of rain with respect to her. Okay, how? Very simple. Okay, so this is the direction of rain. So in this direction she is moving, say VG. on ground only. So that is why Vg is the velocity of girl with respect to ground. But now she want to know in what direction that rain is falling over her, right? So she is taking the comparison, no? So nothing but you can say VRG. VRG means velocity of rain with respect to girl. Okay, how? So it is relative now. So that is why you are taking the direction of the girl in opposite direction. Okay, so this is rain vector which is added to girl in opposite direction. Okay, so you know first vector head is added to tail of second one. Then you know the closing side taken in reverse order, no, will give us the resultant. So that is velocity of rain with respect to girl. So she finds rain falling over her at this angle. Okay, she is moving with Vg speed, whereas rain falling over her vertically down, but she feels that it is falling at some angle, say beta. Okay, so with respect to rain, you know this is beta, so tan beta, or else here you know this and this na, so you can take sine na opposite hypotenuse. So sine beta is equal to opposite by hypotenuse, right? So here Vg is velocity of girl with respect to ground, and this is velocity of rain with respect to girl. Okay, or if you want to know in what direction she want to hold the umbrella to protect herself from rain. Okay, so over here you know opposite known, adjacent known, so you can take tan na. So tan alpha is equal to velocity of rain by velocity of girl with respect to ground. Okay, so what is the given concept? A girl moving horizontally with certain speeds Vg with respect to ground. So whereas rain falling over her at vertically down with speed Vr. Now she want to observe the rain at what angle it is falling. No? So that is you know beta. So this is velocity of rain with respect to girl. Okay. Velocity of rain with respect to girl. In this way, it is easy to solve number of problems. Okay, only you need to remember one point, that is head of first is added to tail of next, and so on. Will give us the resultant. You can extend your concept to more number of vectors also. Over here we have taken only 2 vectors. You can extend it to 3, 4 and so on. So whenever 2 vectors are inclined at an angle theta, diagonal gives their resultant. Okay, so we have seen in case of a flying bird, when the bird stretches its wings down now, it will be moving in the diagonal direction. Or else you see a cutter, that is whenever you apply force on this, you know it will be going in the diagonal direction. So how to find magnitude of this resultant? So you know you take the tail of second one and add it to head of first one, right? Take the tail of second one and add it to head of first one. So extending this forward and dropping the perpendicular, you get resultant. Okay, say magnitude of first vector is A, say second vector is B. So if they are inclined an angle theta, you know this will also become theta na? This will also become theta. Okay, say this is X, this is Y. Okay, so you want to find this. Take cos theta. You know cos theta is adjacent by hypotenuse. If this is B, this is also B. So it is X by B. So X equal to, you know, B cos theta. Okay. Similarly, you can find y also. Okay. Y. That is, you take sine theta. Okay. Sine theta opposite by hypotenuse, you know, it is y by b. Okay. So y equal to b sine theta. Now you want to know magnitude of this resultant. So if you notice, it is a right angle triangle. So mod r square, okay, is equal to, okay, a plus x whole square plus y square, right? So this is expanded in the form of a plus b whole square plus y square. Okay. Now you substitute x as b cos theta, okay, and y as b sin theta. So a square plus x taken as, you know, b cos theta whole square. Okay. Instead of y square, you can write b sin theta, okay, whole square plus 2ax. So you know, b square, if you take common trigonometric identity, that is, you all know, sin square theta plus cos square theta is always equivalent to 1. Na? So this is all mod r square. Then you know, mod r will become root over a square plus b square plus 2ab cos theta. So remember, whenever two vectors are inclined at an angle theta, the magnitude of resultant is given by root over a square plus b square plus 2ab cos theta. So you can find the maximum resultant and also minimum resultant. See, if two vectors are added in the same direction, then you know this angle is equal to 0 degrees now. So put theta 0. Okay. You get a square plus b square plus 2ab cos 0 now. Cos 0. You know, cos 0 value is 1 now. So that is why it will be a plus b. Nothing but you can say maximum resultant. So in order to get the maximum resultant, two vectors must be joined along the same direction. Suppose they are added in opposite direction. Say like this. This is one vector. The other vector is added in opposite direction. Say theta 180. So in place of 0, you take 180. You know, cos 180 value is minus 1 now. So that is why you get minimum resultant. Okay, a minus b. So magnitude of resultant will become minimum when theta 180, maximum when theta 0. So if you know this, it is easy to solve a problem which will be usually given in the competitive exams. Suppose you have given a problem. Magnitude of one vector, say A, is known to you. Say that is 2 units. Okay. Magnitude of one vector, okay, A bar is known to you, say 2 units. But the other one you have not given. Angle between them is also not known to you. But the resultant you have given, say 5. Okay, you want to find the other vector. Okay, how? Very simple. So, you know, resultant always lies in between minima to maxima. So you will be given usually in any competitive exam options, no? Say these are the options given to you. Say one is 2.5 units. Okay. Second one, say 6 units. Third one, say 8 units. Say fourth one, 12 units. Now, let us assume first one is your answer. So first one, you know, 2, second one let us assume 2.5. So 2 plus 2.5, 4.5. And 2.5 minus 2, 0.5. Resultant is actually 5 now. So 5 is not in between 4.5 and 0.5. That means first option is not correct. Now take 6 as your answer. Then 6 plus 2, 8. 6 minus 2, 4. 5 is in between 8 and 4. No? So second option is right. Suppose you are taking 8. 8 plus 2, 10. 8 minus 2, 6. But 5 is not in between 6 and 10. So second option is correct one. Okay. Now we'll do another model related to this parallelogram. Okay. Suppose you have given two vectors are inclined. Okay. It's an angle not given. Okay. Say one is 1, another one is P. You have given two vectors inclined at some angle, magnitude of first one 1, another one P, and the resultant is at right angle to 1 and having magnitude 1. Okay, so you have to find angle between them and this value of P. So what is your question? You have given two vectors of magnitudes 1 and P inclined at some angle. They said the resultant magnitude is 1 and perpendicular to 1. So same magnitude you can take here. No? Right. So this is also 1. Then P square will become 1 square plus 1 square. So P becomes root 2. Okay. So this is angle theta. So opposite adjacent. You can take tan theta 1 by 1. So 45 degrees. If this is 45, already 90 is there, no? So angle between the two vectors. Okay, 45 plus 90, 135 degrees. Okay, so this is your answer, angle between two vectors. Okay, now suppose you have given a problem based on the formula. Okay, based on the formula, that is two vectors P and Q ratio here given. So magnitude of two vectors is 3:5. Okay, and angle between them say 60 degrees, and resultant is also known to you, say 35. So you want to find their magnitudes. You have given ratio instead of magnitudes. Mod R is equal to, right? You can use formula now. P square plus Q square plus 2PQ cos theta, right? So magnitude is known to you, 35. Okay. Ratio given, whenever ratio is given, always it is some multiple. That is why I am taking 3k whole square plus 5k whole square plus 2 into 3k into 5k into cos 60 degrees. Cos 60 value 1 by 2 na 2 cancelled. Okay. When you further simplify, 9k square plus 25k square plus 15k square, right? So total 49k square under root, nothing but 7k. 7 divides 35 5 times, so k value 5. Therefore P 3k na, so 3 into 5 15. Q 5k na 5 into 5 25. So this is the procedure we are doing when ratio is given instead of values. Whenever ratio is given, you should take some multiple. Over here I am taking k, 3k, 5k. Thank you for watching this video. Please like, share and subscribe. Okay, thank you.